Alrighty. Okay, so today we're looking at two things. We're not looking at any graphs today. We're not graphing today. Okay. What we are doing is looking at two things: center and spread. That's it. Center and spread. So when you hear the word center, what does that mean? Middle. Exactly. The middle. The center is the middle. Okay. And spread, or I kind of do, spread is kind of like this. How far apart, right? That's what that is. We have two ways to measure the center: the mean and the median. Median we've done before, right? So you guys know how to find the median. The mean, most of you guys probably already know, but we're going to go over that just in case. So first example. So there's a typo here. It shouldn't be 20 bags. It should be 13 bags. That was a typo. Okay, so change that to 13. Otherwise, it won't make any sense. Okay, so we have 13 bags. 13 bags, right? They each have candy in them, sweets. One bag has 23 pieces of candy. 4 of the bags have 24 pieces of candy. 2 of the bags have 25 pieces of candy. 3 of them have 26 pieces, and then the last 3 have 27 pieces. Okay? So, in other words, there's 123, there's 4 24s, 2 25s, 3 26s, and 3 27s. Right? That's 13 bags. Okay? So first thing we're going to do is calculate the average. Another word for the mean is average. So what is the average, or what are the mean number of candies in those 13 bags? So what's the first thing I got to do when I'm finding the average or the mean? Does anyone remember back from whenever you did this? Add up all the numbers. Add up all values. That's the first thing. Okay, so you're going to need your calculator today, or your phone if you don't have a calculator, the calculator on your phone. Keep that close to you because you're going to be using it a lot today. Okay, so the first thing is let's add up all the numbers. So we got 23 plus 4 24s plus 2 25s plus 3 26s plus 3 27s. Okay, so go to your calculators and add those all up and tell me what you get. 328. Anyone else get 328? Yep, sounds right. That's the first step. Good. First step is done. Once you do that, what's the next step? There's one more step. Starts with a D. Divide by, in this case, it's going to be 13. Good. So divide by total number. In this case, there are 13 bags. So you divide by 13. So 328 divided by 13. So we get, let's see, 328 divided by 13. I get a decimal. Okay, it's 25.23076 so on and so forth, right? So today we're just going to go three places. So 25.201, or sorry, 230. So the 0 is the third number after. The 7 behind it says we got to go up one. So 25.231. That's going to be the number we write down. Good. Okay. So the average is 25.231, around 25. The average is, there's an average of about 25 in each bag. Okay. That's the mean. Okay. Not too bad. Now, find the median. I want you guys to find the median right now. We've done that before. That one's not new. You guys have done the median before. So what's the first thing we got to do when you're finding the median? There you go. First thing we got to do is get them in order. They're kind of already in order. 23, then 4 24s, 2 25s, 3 26s, and then 3 27s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we start crossing out numbers, right? Until we get to the middle one or the middle two. Yep. In this case, it's just going to be a middle one. And that is the median. Okay. So, what do you notice about the mean and the median? They're pretty similar. They're pretty close, right? If I rounded the mean, it would be 25, right? 25. So they're pretty close to each other. Sometimes that'll happen. Sometimes they'll be close. Sometimes they won't be close. Okay, so you can't always assume that they're the same or they're going to be very close. Okay. All right. So now that's the center. Center is not too bad. What we're going to spend our time with is spread. Spread's not too bad either, but that's going to be new. Spread is brand new. We haven't talked about spread really. We've talked about range, but we haven't talked about two things: standard deviation and interquartile range, IQR. Okay. Okay, so what I want you to do first, we have two sets of data, right? Imagine these are very small classes. Set A is a very small class of 5 students. Set B is a very small class of 5 students, okay? They each took the same test, okay? So what I want you to do is I'll give you about 3 or 4 or 5 minutes or so. I want you to find the mean for both A and B and the median for both A and B, okay? So I'll give you about 3, 4, 5 minutes to do that. I want you to do letters A and B. Find the mean for both, find the median for both. All right, so what's the mean? What's the average for both of them? Right on the dot, right? 70, no decimal. 70 for this guy, 70 for this guy, right? Same. They have the same mean. The average student in the first class scored the same as the average student in the second class. That doesn't mean they all scored the same. It means the average, right? If I find the average score on a test for you guys, that tells me something about all of you, not just one of you. Okay? The median, what do you know? What was the median for each? Same, smack dab right there. They both had 70, right? So here's the thing. I know what's the same, the mean and the median, right? You don't have to tell me what the same is. Tell me what the differences are. So what I want you to do right now, on your own, I'll give you about a minute or two, jot down bullet points. You can do bullet points, so they're okay. What are two things that are different about A and B, set A and B? I know what's the same, but give me 2 bullet points for what are different about A and B. Okay, so I hear a lot of good words, a lot of good things. So tell me, can anyone tell me what's one thing they're different?
They both have a different range, like different minimum and maximum.
There you go, right? Range is the biggest minus the smallest, right? So if I find the range of set A, that's going to be 115 minus 25. That's 90. Big range, right? 25 is way over here, 115 is way over here, right? If I do the same thing for B, 65 to 75, that's a range of 10. 190 is a lot bigger than 10, right? That's a good one. That one's a good one. That's definitely true. What's another thing? Anyone else see anything?
What do you call like Q1 and Q3?
Just Q1 and Q3.
Oh, well, those are also different.
Those are also different, right? Because set A goes a lot higher, right? I had one student in set A got a 25, really low score. 40, still a low score. 70 is a C. 100 is a perfect, right? 115 is even extra credit on top of the perfect paper. Set B, 65 is about a D. 69 is a D plus, C minus. 70 is a C. 71 and 75 are both C's. There's a wide disparity in A. There's a lot of differences. There's a lot of gaps in between them, right? In B, there's not a lot of gaps in between them. They're all pretty much clumped together. It's a cluster. Okay? Yeah, that's the differences. Well, how do we measure those differences? Well, one way is IQR. The other way is standard deviation. We're going to talk about standard deviation first because that's the big one. That's the one we're going to be talking about a lot next week. Okay? So let's skip letter D and let's go to E real quick. We'll come back to letter D, but let's go to letter E because that's the one we're going to be using a lot next week. Okay? One measure of spread is called standard deviation. Okay, so when you hear the word standard, what does that mean? Basic, average, right? If I go to a car dealership and I want your standard edition of your car, SE, right? Sometimes you'll drive by cars and on the back it'll say SE. That means standard edition, right? It means it's not going to have all the bells and whistles, right? It may not have leather seats, might not have tinted windows. You might have to do that on your own. You know, there's bells and whistles won't be there, but it's the same car, right? It's your average car. It's not good. It's not bad. It's in the middle, right? Standard. What does deviation mean? What does it mean to deviate? Different, right? Whatever the path is, you've gone away from it, right? Gone away from the path, right? One word that describes. Sometimes you'll hear in the news when they're talking about people who've committed crimes, they'll call them deviants. It's not an insult. It's just another way of saying someone who's different. They've deviated from the path to being a good citizen, right? They've deviated. Doesn't mean they can't come back, but it means at that point they've deviated, right? They've gone away from it. That's what deviation is. How far you've gone away from something, right? So it's the average distance you've gone away from something. From what? The mean. Okay? So the first thing, standard deviation's got 7 steps. It's a lot of steps, but trust me when I say the steps aren't that bad. Okay? Like the first step, list all the numbers. Okay? I can do that. So we're going to list data set A first. We'll do data set A together. B, you guys will do. So A, the first number in data set A is, what was it, 20? 25, and then 40, and then 70, and then 100, and then 115, right? Those were the 5 numbers. That was step 1. Step 1, check. Step 2, I got to find the mean. Well, I already did that, right? What was the mean? Okay, check, did number 2. Number 3, okay, now I have to subtract each value from the mean. See how far it is away from it. Yeah, what happens when I go 25 minus 70? I get a negative number. That's okay. That just means, all that means is you were 45 away from, that person was 45 points away from the average score on the low side. That's why it's a negative. The second one, same thing. They're below the mean. The third person was right on the mean, so their difference is 0. They didn't deviate at all from the mean. The next person deviated again from the mean. And then the last person deviated again from the mean too. Okay, that's the step 3. Subtract them. Okay. We got some positives, some negatives. The next step is to square them. Square those numbers. Square means multiply it by itself. So for example, if I square 45, negative 45, that's negative 45 times negative 45, which I believe is 2025. The next one is negative 30. I got to square that. When I square it, it becomes 900. The next one was 0. So 0 squared is just stays 0. The next one looks familiar. It's 30, just positive 30. Well, if I square it, it's going to be the same because 30 times 30 makes a positive 900. And then the last one's 45. That looks the same. When I square it, it's going to be the same. 2025. That was step 4. We just did step 4. Yeah, before we do that, before we go to step 5, what do you notice about the numbers from the step before? So compare these numbers. What do you notice about these numbers versus these numbers? Yeah, it kind of seemed, yeah, these numbers are a lot higher, right? I squared it, right? When you square something, it goes up a lot higher. It inflates the number. I wish I could square the number in my bank account right now, right? That'd be nice, right? It inflates it. That's what we're going through inflation right now. That's what inflation is. Inflation is when things go up in value for no reason at all, right? For no reason at all, numbers are going up. Housing values are going up. The amount of money I got to spend when I'm getting a gallon of gas goes up. Those numbers are going up for no reason at all. That's why it's inflation. Well, it's not no reason. There are reasons behind it, but inflation means the number goes up for no reason at all, really. Okay? Mhm.
I was just thinking it just to prevent scarcity.
Yeah. Yeah, it has to do with economics. Yeah, you guys will learn about that in seniors. Economics is to talk about all of that stuff. You'll learn about scarcity. You'll learn about all of that stuff in economics next year. What's that? I mean, it's interesting. It's interesting to see how the economy works. Why when I go buy this calculator, why is it the same price? Why does the price go up? Why does the price go down? You ever wondered about those things? That's economics. It's based on economics. Something called supply and demand. When supply is high, that means there's a lot of it available. When supply goes down, that means there's not a lot available. Like for example, those of you that play video games, PlayStation 5 right now. Right now, you can't buy it. There's because you go to the store right now, you cannot buy a PlayStation 5 because they're not in stock, right? So if you go to the store, you're paying about $300, but you're paying about $400 for a PlayStation, but you can't get one. So the supply is low, right? But what happens to demand? People want it. That means they can raise the prices, right? That means they can raise the prices. So if I wanted one, I could go on some website and buy it for $900, right? That means that's what it is. Right now with the cars, right? If I wanted to go buy a car, I got to pay a lot more than I did 2, 3, 4 years ago because supply is really low and people are still buying cars, right? That's kind of the reason why gas is the price it is, right? We don't have a lot of gas in supply, but people are still buying gas, or still buying it, right? So supply is high, or sorry, supply is low, demand is still high. That's why the gas prices are going up, right? During the pandemic, when no one was going anywhere, gas was like $1 and change, because supply was extremely high and demand was low, right? So how do you lower the gas prices? Stop buying gas. But we have to, right? Because you got to get to work. Exactly. How do you not go anywhere? Yeah. So it's like we have the answer, but we can't do the answer unless we lose our job, unless we can't go to school, unless we can't, So it's that's why the prices are kind of fluxing right now. Okay. So one of the things got to change. Either supply's got to go up, we got to get more oil, or people got to stop driving. Well, people can't stop driving because they got to go to work, they got to go to school, they got to do things, right? You have to be able to go to the store to buy food, right? So hopefully, so that's the issue that they're solving right now, whoever they are. Okay. Yeah, whoever they are. Okay. Hopefully they solve it very quickly. Okay, so next step, add them all up. Add them all up, right? So let's add them all up. And what do we get when we add them all up? Big number. I think it's 5,000 something. It's 5,800. I don't think it's, is it 25? Oh, wait, no. It's 50. Yeah. 5,850. Pretty big number. Okay, the next step, divide by the total number. So divide that number. How many numbers total were on our list? 5. So I divide them by 5. I got 1,170. What do you notice about that number compared to the numbers on my list? It's a lot higher. It's inflated. Why is it inflated? Because I squared them, right? So I got to bring them back down to earth. I got to bring them back down to earth. How do I bring that number back down to earth? Square. What's the opposite of squaring? Square root. Take the square root. So I got to take the square root. That's the last one. So when I take the square root of 1,170, there we go. So go 3 numbers past the decimal, so 34.205. I don't have to raise the 5 up because the 2 behind it says stay. So 34.205. That's standard deviation. So the standard deviation for set A is 34, a little over 34. A little over 34. Okay. So what I want you to do now, I'm going to give you about 4 or 5 minutes. If you need that, I want you to do the same thing for data set B. Tell me what the standard deviation for data set B is going to be. Same steps, different numbers. Okay, so the standard deviation for B, I think it's 3 point something. Yeah, it's 3 point, let's see. Square root of 10.4, yeah, 3.22, yeah, we're going to round up 5. So 3.225, 3.225. So look at the table. What do you notice about the table versus the table above? A lot smaller. The numbers are a lot smaller in this table here. Look at these numbers here. Look at these numbers here. Look at this number, right? Numbers are a lot smaller. Why are they smaller? What's causing those numbers to be smaller than the table for A? There's not as many gaps. Yeah, they're all pretty close together. These numbers are pretty close together. So since these numbers are pretty close together, the standard deviation is very low. These numbers over here have a lot of gaps in between them, have a lot of, the range is bigger, right? So their standard deviation is pretty high. Here's the question. Test question. Possible test question. How could I, let's say these are 5 students in my class. I had a 6th student who was absent for the test. They took the test. I haven't graded it yet. What score would they need to get for this number here to go down? Would they have what number? So this number is the average. Well, let's come back to that question. Let's do the last question first. F. Interpret it. Maybe this will help. Interpret it. So this is what it means. I put 2 sentence frames on here. They're both the same sentence frame. One's for data set A, one's for data set B. So when I say interpret, I mean, I'm like, what does the number mean? What does the number mean, right? How many times have you sat in a math class and we solved a problem and x equals 3? You're like, okay, what does that number mean, right? In statistics, everything means something. Everything means something. There's a reason why we do what we do in statistics, right? We use math, but there's a reason. So those numbers mean something. Like the average of 70. Why is the average 70? Because that's the middle, right? That's the middle. Same thing with the median. Why is the standard? So for A, on average, each value in data set A is, what was the number, 34? 0.25, 205. And then the lower one, B, was this. All right, so on average, so yeah, you got to write the in because this is what standard deviation is. Guarantee you on the next test, I'm going to ask you to interpret, because in statistics, things mean something, right? So what does the number mean? On average, each value in data set A is about 34 points away from the mean. Does that mean every single number in data set A is 34 points away from the mean? No. On average, they are. B, on average, each value in data set B is about 3 points away from the mean. They're a lot closer together, right? That's what that means. On average, how far? Now, is every student in this class 3 points away from the mean? No. None of them are 3 points away exactly, but they're on average, okay? So let's go back to my question. My question was, how do I get 34 to go down with another student? I can't change the numbers. I wish I could change grades, but I don't have that power. I don't have that superpower, right? I can have another student take the test, though. Let's say there was a 5th student that took the test. So up here, a 6th student took the test. What kind of score would they need to get for that 34 to go down? Yeah. Not less. That actually would make it go up if it was less than 25. The number needs to be what? The number needs to be closer to the mean than this, 34. It needs to be closer to the mean, because that's what the number describes. So any number that's closer to the mean than 34 points. So they could score anywhere from 36 to 104. Anywhere in between there they could score, and 34 would go down, right? Because let's say that person scored a 70. First thing I would do is subtract 70, right? Which is 0, which is another 0. So this number wouldn't go up, right? It would stay the same. But instead here, what would I divide it by? 6. So what happens when the bottom number on a division problem gets bigger? The overall answer gets what? Smaller. So this number would go down. This number would go down. Therefore, this number would go down. Okay? This one is a lot harder. Set B is a lot harder to get the standard deviation lower because they're so close together already, right? So to get data set B, they would have to score from 67 to 73, 3 above or 3 below or something in between for this number to go down. Okay? One of the things I do, one of the very first things I do when you guys take a test is I find the average score. And then I find the standard deviation. Because if I have a standard deviation of this, I'm like, you guys are all over the place. What happened? Something happened. So then I got to go look to see. Here, oh, you guys are pretty much all around the same. It doesn't tell me if you did good or bad. It just says you guys are pretty much all around the same. Okay? So but you guys are about 6 to 10 points away. Your standard deviation on a test is usually about 6 to 10 points, which is good. You know, there are some variety, but there's not a lot. Okay. Sorry. So last thing we gotta do one more thing. We didn't do D. So to find the IQR, you're gonna go Q3 minus Q1. So I need to find those out. So we need to find out Q3 and Q1 for each of them. We've done that before. We've done Q3 and Q1. So let's see. 25, 40, 70, 100, 115. So before I find Q1 and Q3, what do I have to find? The median, which is 70, right? We knew that already. So that's the median. Everything below the median. The only two numbers below the median. So what do I do to find Q1? There you go. Add them up, divide by 2, and I think you get 37.5. No, 32.5. That's Q1. Same thing above. There's only two numbers below or above the median. So add them up, divide by 2, and I think you get 107.5. That you've done before. You've done that before. That's not new. The new part is subtracting them. So IQR equals Q3 minus Q1. So in this case, it's going to be 107.5 minus 32.5, which is 75. What would the IQR be for data set B? So we know 70 is the median. Below the median, I only have two numbers. So if I add them up and divide by 2, what do I get? 67. So 67 is Q1. Above the median, I only have two numbers. Add them up, divide by 2, what do I get? 73. Okay. So subtract those two numbers. 73 minus 67, I get 6. So you notice it has a smaller IQR than the top one does. Just like standard deviation. B had a lower standard deviation than that. Okay? Alrighty. Okay, so tomorrow we will tape those in. Remember, I could be checking them. I'm only checking second semester. Okay? So you have 2 weeks to get your notebook in line, to get your notebook in order. If you're missing any, they're all on Google Classroom. So you can literally just go copy them into your notebook. Mm-hmm. Yes, they have to be in order. Yeah, order of how we did them.